Hi, everybody. My name is Christy, and I work here at Tagged. I'm part of the marketing team. And a little bit, does anybody know what Tagged is? Raise your hands, anybody? That's good. So for those of you who don't know what Tagged is, we are a social discovery site. It's where you come to meet new people. And we've been around since 2004 and profitable since 2008. We have 300 million users worldwide, and we have about 200 people who work here at the headquarters here in San Francisco. We have a great culture. We're an awesome team to work with. We are really excited to be hosting the Zipfian Academy meetup again. We've had a great experience with them, and we actually brought on one of their graduates about how many months ago? A few months ago.
Yeah, December.
So without further ado, Katie.
Yeah, so thanks everyone for coming. Just to give you an overview of kind of how the night's gonna go. So we have here Ben from Opower, Fernand from Change.org, this is my colleague Jonathan from Zipfian Academy, Brian from BrightBites, Ash from Lumiata, and Michael from Code for America. And we're gonna first give a little introduction to ourselves and what we do here at Zipfian Academy. And then we're going to kick off the panel moderated by Jonathan. Yeah, so let's get going. So Zipfian, for those of you who are not familiar, is a training program for data scientists. We're headquartered here in San Francisco. So we have quite a few of our about-to-be graduates here in the house. Want to raise your hands? There's a little cohort of them over here. So they've spent the last 12 weeks immersed in learning machine learning, statistical analysis, big data management, and software engineering. And we work with companies like Tagged, like Lumiata, like Change.org, to help people transition from academia or from sort of like analytical roles that are slightly less technical, or from engineering that's not software engineering into data science positions. We're also kicking off something I'm really excited about, which is a series of shorter form workshops for people who can't give up their jobs, spend 12 weeks with us learning data scientists and becoming one in the next 3 months, but are really interested in learning more about these kinds of topics. So some of those are coming out really soon. If you have particular things that you'd be interested in learning, say machine learning, how to predict user acquisition and churn, statistics, things like that, that you want to know more about, please come talk to me after the meetup. We're really driven by what people want to know about, so I want to know what you want to know so I can help you learn that. And that's pretty much the introduction to us. The other important point is we're currently accepting applicants for our class beginning in May 2014. So it begins on May 12th. It's 12 weeks boot camp style learning of data science. And if you're interested in doing something like that, you can talk to me or Jonathan or Ryan or all of our soon-to-be alumni who are currently here and can tell you about their experience in the program and sort of how they ended up there and what they are hopefully going to do afterwards. Yeah, and fundamentally, thanks a lot for coming. We're really excited about how much momentum that I'm seeing with this meetup and all of you coming. And please, if there are things that you want to see, want to know, I really want to hear from you about what kind of forums you want to see exist in terms of job placements and learning and things like that. So let's have the panelists come up here and grab a seat on one of the stools here. I think we'll save this one for Jonathan, and we'll have you guys pass this mic around. So of course we're going to kick off with a short introduction to each of the panelists. Jonathan has some questions he's going to ask. They come from myself and from the team at Zipfian, and then what we're excited about is delving into about half an hour of your questions of this wonderful group of data scientists in the social good space. So what do you want to know from them? So in about half an hour, we'll give you the opportunity to ask whatever you want to know. So thanks a lot for coming.
Thank you, Katie. Thank all of you again for coming here. And thank you, Katie, for organizing this. She runs all the meetups and the community at Zipfian, so bringing great people together. Without further ado, I'm the CTO, co-founder of Zipfian Academy, head up the instruction, curriculum, teaching in the classroom. So if you have any question about data science, happy to answer them afterwards. Jumping right into the panel here, a lot of the questions I'm going to kind of gear towards the unique things about doing data science in the social good space. And before we start, I would just want all of the panelists to give a 1 or 2 minute introduction into who you are, what your company does, and what you do for your company.
Does this microphone work? Is there an on switch to it? I can also use yours. Can everyone hear me if I just yell?
Pass around the other one while you figure it out.
Yeah.
Hi, everybody. Can everyone hear me if I talk through the microphone? Yay. Okay. Hi, my name is Michael Magursky. I am the CTO of Code for America. We're a nonprofit located here in San Francisco, and we run a fellowship program with 10 city governments each year that we've been running for about 4 years now. Code for America is sort of an interesting place with data. We actually work with city governments and county governments and state governments. So that means that in a lot of data issues, we're actually working with the primary sources of data. The people who track parks, deal with building inspections, figure out where parking fines need to go, and basically are the kind of original, proper, first primary sources of information. So it's kind of a weird spot in the funnel of data to be at. And in a lot of cases, what we're doing with these cities is helping them understand how they should open this stuff up to the public. One thing that you probably can guess about city governments and county governments is that they're really famously behind on technology issues. And us here in Silicon Valley, Code for America, are in a place where people are generally famously ahead on technology issues. So a lot of what we're doing is trying to kind of bridge that gap in both directions. Bringing cities up to speed, but also trying to help the technologists and designers that we work with understand what speed is for city governments and understand a lot of the issues there. And if you're familiar with the Gartner hype cycle, really the bridge we're trying to build is over that trough of disillusionment right in the middle of the Gartner hype cycle. In addition to the fellowship that I mentioned, where we work directly with city governments, we have an international community of civic hackers personified by the Brigade program. I'll talk a little bit more about local stuff there in a couple of minutes. And we're producing projects like an API around different projects that people are working on, tracking all kinds of different issues that people are working on in different city governments around the US and around the world. Right now, one of the emerging issues that we see in data science that's particularly interesting is ETL, which is short for extract, transform, and load. And this is sort of where, in a lot of cases for governments, the rubber really meets the road of data science. This is the situation or the process whereby people in one department and another department can kind of bring their data together. So actually, if you Google for ETL for America, you'll see a really excellent blog post by Dave Carino, who's one of our former fellows from 2011, talking about ways in which organizations who deal with data science can help city governments kind of get their heads around moving data around and opening data. For those of you who live in either San Francisco or in the East Bay, there's 2 weekly meetups of our brigade that you might want to go to if you're interested. If you live in the East Bay, Oakland City Hall on Tuesday nights at 6:30 p.m. hosts the Open Oakland Brigade. They meet every single week. And if you live here in San Francisco, our headquarters at the corner of 9th and Natoma in the south of Market area hosts the San Francisco meetup Tuesday nights, 6:30 p.m. Thank you.
Hello, can everyone hear me? I guess so. Hello, my name is Ash Thomley. I'm the CEO and founder of Lumiata. And our focus is how do we help ensure that everyone gets the best care possible by combining the best of data science with medical science. Fundamentally focus on how do you democratize medical science to everybody so that everyone here has that capability to understand what their data actually means for them, that a nurse can make the best decision to help them get to the right care path, and that the physician or a care provider, wherever they may be, make sure nothing is being missed. We're a coastal back company. We're in the San Mateo area. If you ever guys are down there, we're up here, and we're one stop away from the Caltrain station. So come on by and visit, and love it. And we're also going to be exposing our API pretty soon as well to people, so that basically you can take advantage of it and build whatever other health apps you guys are looking to do. So looking forward to it. Cheers.
Hi, I'm Brian. I'm a data scientist at BrightBites. Our mission is to really change the way people learn through data, and we do that by building a platform that kind of unites data, research, and best practices. Our focus right now is on K through 12 schools in the United States. The people that are real passionate in education, but frequently don't have all the data they need to make the best decisions. And so we kind of present that data to them in a way that is engaging and actionable. Hi, I'm Ben. I'm from Opower. I'm on the data science team. You may know about Opower if you are a PG&E customer and you get an insert in your mail every month that says how you are doing with your utility bill compared to your neighbors. That might be how you know us, but the goal of our company is to help people to save energy. And so we partner with utilities. They basically pay us to get people to save energy. It's a little counterintuitive. Part of it is government incentives, and part of it is that we, in addition to reducing overall energy usage, have programs to reduce peak usage. There are real market forces and economic reasons for them to pay us for that as well. So those are the two of the main things that we do and the effects that we have. The data science team we have at Opower is relatively new. My background is in machine learning. I did my PhD in machine learning and came straight to Opower from there, so this is kind of my first real job. That was a little over a year and a half ago. And then about 6 months ago, we formed this data science team because there have been a couple of us around the company doing machine learning type things, or real machine learning, in service of several products that we have, and we decided to consolidate those efforts, and we're growing that team now. One of the, not necessarily unique, but sort of the way that we organized the team, that we purposely, the way we constructed it is that we put it inside engineering. So we are all engineers on the data science team. We have two different roles. One is a data scientist, which is sort of a machine learning PhD equivalent or specialist, who is also at least a junior engineer. And then the other side is a data engineer, who is a basically a senior software engineer who is also conversant or familiar with machine learning. And we embed ourselves in different product teams so that we are always basically have a product team that is willing to use the output of whatever we build, as opposed to just doing research off on our own, kind of throwing over the wall. And a few of the products that we work on are the smart thermostat. We have a behavioral demand response program that sends out basically messages to people that just says, tomorrow is a peak day, use less energy, and then you'll get a rebate. We do that through the utilities. And there's several other programs that are products that we work with. We are relatively new, so we've just gotten our hands dirty.
Hi, I'm Fernand. I'm lead of the data science team at Change.org. So for those who are not familiar with Change.org, it's the world's largest petitions platform. We have over 60 million users and 4,000 declared victories. And more than 20 million users on our platform have actually signed a petition which became victorious. We have offices in about 18 different countries. So specifically around the data science team, we're currently 6 members, and we work a lot with different parts of the company. So a lot with the campaigners around identifying which petitions are potentially really interesting petitions, and how can we understand the underlying quality of a petition, sort of help petition creators make them better, recommend petitions to users, make sure that they have the best content in front of their eyes. And we also work a lot around fraud detection. And yeah, if you want to talk about data science for change, come talk to me.
Awesome, thank you panelists. You can actually hang out to the mic down there. We'll probably just do a bunch of back and forth. But to just kind of give an overview of the some of the questions and the panel in general, there's going to be about 20 minutes, a half hour of questions that I prepared for the panelists, and then about a half hour reserved for any questions that the audience might have. So if you do, through the course of the questions I'm asking or the panelists talking, have some questions, write them down, remember them, and the whole second half of this is going to be geared towards you learning what you came here to learn from these awesome data scientists and leaders in their field. So Again, all the questions I'll ask, they hopefully apply to all of you. If they don't apply to you, due to your company or your role, feel free to just pass the mic along. You don't have to answer every question. And just kick things off, one of the things that we often hear is that there's not enough data scientists, there's way too much data. Even data scientists who are at companies have 1,000 people kind of breathing down their necks to get reports, statistics, models built. So how do you either manage and triage that so that you focus your time where you can have the most impact? Or kind of a converse of what are the biggest challenges that you often have to overcome to make sure that you are doing the things to move the needle for your companies?
Sure. So this is definitely an issue we have. So we have 2 data scientists and 1 business analyst, and our company is about 200 people, and we have data requests every single day from all around the place. And so when you think about data requests, there's a bunch of important things. First of all, you need to understand why they want the data. And you also need to understand if they have the tools in hand and also just the information in hand on making the right decision if they had this data. Like, are they asking the right question? That's actually the most important. And we actually turn down a lot of data requests because we find out that the question they're asking is maybe an interesting question, but it's actually not going to help them. It's not what they want. So we usually go around and then talk to them and figure out what actually they really want. And afterwards, we make sure that we're able to automate these processes and data requests so that we are not saturated by just doing SQL queries or reporting. So every time we see a data request, we then make sure that we can automate that in some kind of way. And it's been working pretty well, where our bandwidth is not that saturated right now by data requests because if you're working closely with all the people asking you for information, you figure out a bunch of patterns which you can then automate.
So at Opower, we actually have a few different teams that kind of deal with this problem. We have an analytics team, which is separate from the data science team. I guess the way I describe the difference between the analytics team and the data science team is analytics is, their job is to measure sort of known quantities. One of the main things they do at Opower is measure the impact of our savings. So all of our programs, they measure, and report those savings. And not only does that, go towards our our stats on our webpage, but actually we get paid based on that as well. They also service a lot of these one-off requests for some sort of analysis. The data science team is more about building tools that predict unknown quantities, and those go into products. So we actually, fortunately, kind of deal less with this, but I can at least speak to how the rest of the company deals with these sort of data requests. So there's the analytics team does some of it. We also have professional service engineers that can, gather some data and do SQL queries. I do know that they turn down requests, because you do have a large volume. You need to kind of consolidate your efforts around the requests that are important. And finally, we have a team that is works on building BI tools that are internal facing and help various teams, depending on who is serving, to understand, get what they need to get out of the data.
Yeah, I see the same problem globally and locally within my company, and I kind of look for the force multipliers. And the force multipliers are first education, so I spend a lot of time teaching internally in my company and externally so people can better understand data and ask better questions and better understand the tools and whatever tool they happen to be using. It could be Excel, it could be R. And then another force multiplier is, again, building out tooling. So I work with the engineering team to build out tooling not only for current needs, but kind of forecasting future needs. So I think those are the ways to kind of leverage a limited amount of time and bandwidth for data scientists.
I want to take a little different track because actually we kind of have the opposite problem in one sense is we keep saying where's any good data. In health actually it's very hard, and even if you go to things like electronic health records and everything, people say, oh yes, it's wonderful data there. About 20-30% error rates and a variety of other issues are there. So one of the things that we deal with a lot is how is it you can derive and distill good analysis or good insights from actually very dirty data or very unstructured data that happens to be there. So in one way, pretty different from trying to say an overload of data. It's we're always continuously screaming, where can we find more data? And on the other side, we're not so much trying to create reports, I would say. I mean, there's a lot of people doing BI tools. Fundamentally, what we're really trying to do is how we can synthesize the data about an individual to really predict what's going on, both in the short term and the long term. So how can we really understand what's going on with that patient's health? And so it's very much to that predictive side of things. How can we create that real clinical model of that patient or that individual and understand what's going on? How can we leverage this entire data about populations, about medical science, digitized, etc., and be able to apply that to do that? So a lot of our efforts are how do we take data, structure it, and distill that down. So it's a lot of learning aspects. And we do a lot of curation as well. So there's a lot of, half our team is physicians. So you can think of our entire company literally made up of either data scientists and or clinicians, because what we're doing is, in health, it's a place where your error rate can be very low. It's okay if I suggest you the wrong movie recommendation. It's not okay if I suggest you the wrong treatment. And so how do you ensure the fact that you're always delivering valuable, insightful, and correct data is a lot of what we spend our time doing. So in some ways, a bit different from other places, but I think health is a very different domain, though in some ways has many of the problems of others, but because of the way it is and the care that we have, it is a little different.
I'm going to have a dirty data off. I think education has dirtier data than medical. Throwing down the gauntlet.
Oh, damn. Yeah, at Code for America with cities, we have a slightly different problem, which is to try to educate the type of analyst who is in a kind of data science position in a government. Because I think in a lot of cases they are even more out of balance with their constituents, especially with open data and open records laws. You might have a few dozen analysts in a city with a few 100,000 residents. And so at the same time, those people are dealing with email systems like Oakland's that only allow them to email a 5 megabyte attachment and have done so for 10 years. So you've got these situations where open records, open data, all this kind of stuff has to be practiced. And for a lot of these folks, it sounds more like a buzzword than like something that's accessible to them. So for us, it's all about education and showing a lot of these folks very basic, simple tools and simple techniques that they can use with the tools they have already that don't involve calling their Oracle rep and getting them on the phone with their SAP rep.
Great input, guys. Kind of going off of, I might be slightly biased, coming right off of that comment, but going on the kind of open data path, we hear a lot of people saying open data, governments are opening up all sorts of their data sources, they're putting bills online, they're putting all sorts of records from anything from 311 requests to police records to when trees were planted. And if this is applicable to you, how do you leverage data that's open data? And this could be anything that's just publicly accessible. It doesn't have to be government data, but open data in the sense that you, your competitors, anyone else has access to it. And how do you leverage it, and how do you deal with the challenges of what that entails?
I guess we're on the side of helping other people leverage it. The challenges, yeah, I'm trying to think of how to answer this question. I mean, open data is what cities have to be able to do. So in a lot of cases for us, it's really not so much about just leveraging the data, it's much more a case of trying to help these analysts inside city governments understand why people might be knocking down their doors asking for this stuff. In a lot of cases, they've worked whole careers never being asked this stuff by people outside of the city or outside of the county, and all of a sudden now there's people emailing them, knocking down their doors, kind of walking into the office, asking for zip files, asking for CSVs, asking for shape files. So in a lot of cases we're on the other side of the fulcrum from normally where you talk about leverage, the kind of really difficult place at the short end of the lever where somebody is being kind of pressured pretty hard in order to open this stuff out. So a lot of it really has to do with helping them understand what it means to leverage this stuff so that they can help satisfy those requests.
So in health, I mean, Todd Park, who's now, I guess, the CTO of America, but previously that was heading of, over there at ONC and HSS, was one of the forefront people to really push for opening a lot of the health data from HSS and ONC. And, for as a health startup, I would say, that was a huge, huge event. I sort of think of data as fuel, right? But also realize it's very raw, right? And like anything else, needs a whole lot of processing to actually start becoming usable. So open data is fantastic, but the question is, there is a lot of work to do to utilize it, to actually put it to work. And a lot of things, what happens when you look at the data that's provided is that at times it's aggregated to the point where it only answers a very simple set of questions and does not necessarily allow you a simple way to be able to connect it within the broader scope of the rest of the data provided. So as a result, you sort of get these, not necessarily data silos, but very disconnected points of data, which by themselves do not allow you to sort of connect the dots. So what I would say is it's a fantastic resource for people. I mean, everything from, you talk about places or maps, you talk about GIS files, you talk about records, you talk about bills, you talk about a variety of things. These are really opening up avenues for extraordinary amounts of innovation, right? It's kind of like being provided cash, but in a different format. And so for that, I would say, it's key. And a lot of the stuff that we've built at Lumiata has been leveraging a lot of this open data, and in fact, from things like that, PubMed, WHO, etc. But one of our learnings, obviously, from all of that is it takes a lot of time to go to actually transform those data sets into something that's really usable, that allows you to apply that to real-world problems in a way that therefore is applicable and meaningful. So.
Yeah, this is really close to the heart of what BrightBites is doing right now. In education, there's data that's open, but that openness isn't really usable. So there's federally stored data, census data, data from National Center for Education Statistics. That data tends to be error-prone and a little older. If you drop down to the state level, you have much more diversity, but it's much more current and complete. But ultimately, the schools are the holders and the guardians of the best data for both timely and accuracy, but getting it from each individual school of the hundreds of thousands of schools in the United States is a big challenge. And that's really kind of what we've been working on. So I've spent a lot of time thinking about this. And so the way we think about it is we call this the data value chain, and it starts with locating the data. So for us, that's a non-trivial task, and that's actually non-trivial in most open data projects, is to locate the data. Once you've located the data, you have to acquire that, and there's various tools, typically some kind of either human web scraping or computer web scraping. Once you've actually acquired the data, you need to process it, and that's a lot of work. That's the 80 to 90% of data science. And then once you have that, you kind of integrate that with the data that you already have. And from there, you kind of are able to do the fun stuff, and that's the analytics, visualizations, statistics, machine learning. And then we think about the kind of the last component is how do we expose that data? So is that data exposed through an API? Is it through a database? Is it through a white paper? Like, how are we making that data accessible to people? So we're just kind of walking through that data value chain as we approach that problem, but having that kind of general heuristic approach allows us to kind of see the forest without looking at each individual tree.
At Opower, actually, open data is a relatively small part of what we do, because one of the big competitive advantage we have is that through having partnered with all the utilities that we have partnered with, which is the majority of the big utilities, or actually 95% of the big utilities in the United States and a lot abroad, we have access to, kind of the only ones who have access to individual home energy data, it's billing and advanced meters and smart meter reads by the hour. So that's actually the large majority of the data that we deal with. We have many terabytes of this type of data. We do integrate a little bit with some other data sources, because according to your definition, weather data kind of falls into that category. It's, we just contract with Weather Underground. For example, we use weather data to help predict energy usage, either at individual hours or over months. That's actually most of the extent of how we use open data, kind of on a large scale. There are a few sort of survey data type things that we integrate, and the analytics team kind of does a little bit of that. The truth is that it's a really small part of what we do.
So a specific example where we use open data is what we call decision makers. So decision makers is basically the person to whom the petition is addressed to. So a decision maker is extremely important, because if you don't target the right person, you are much less likely to win. And usually finding the right person to target is usually extremely difficult. So it's something we're working on to make sure that people, basically to optimize the chances of victory for petition starters. And for example, where we use open data is Congress information. So we pull the list of all the Congress people, the senators, the mayor of San Francisco, and other kinds of government open data sets which we can use to sort of build a set of decision makers.
Awesome, awesome. One of the common themes that I feel like keeps coming up in everything you guys are saying is, one, education, but not education necessarily in the sense of what we do at Zipfian, but just communicating to coworkers, citizens, volunteers, and conveying either what you've done or how to do what they need to find out. So along this track, how do you guys envision, if you have a specific thing that your company does, it would be great to focus on, making data science and data more accessible to a broader audience? And this could be non-technical folks through visualizations, through opening up a tool that they can access through a web browser, or even to technical members on your team through some collaboration efforts, and make them be able to help you help them.
Yeah, so we have a great example of this about almost a year and a half ago now. The first data science product of Change.org was a machine learning-based email targeting tool. So basically, we wanted to replace manual targeting with machine learning. So basically, for a set of given petitions, predict the probability that a user was going to sign this petition. And there were a bunch of constraints around this project, and one of them is that campaigners, so the people who were staffing some of the petitions on our website, needed editorial control. So they needed to sort of figure out how many people should be reached out for this petition, how many signatures they needed to this petition. So they basically needed an interface to a machine learning tool. And campaigners are low tech. They have zero knowledge in statistics or math. So it was a really interesting experience around communicating how they use this tool. And they're actually now using it in production, and they're actually using it in a sophisticated way. They are looking at probability graphs of users ordered by probability of signing for multiple petitions, and they can set different confidence thresholds depending on what their goals are. And the education process for that kind of project is extremely important. You need to make sure that they basically have exactly the right context they need to use the tool, so that they still need to understand how machine learning works in terms of like an intrinsic fashion. They don't need to know anything about the models, but they do need to know around what machine learning is, how it uses data, how it trains data, and how it predicts. And it's not easy, but it's doable.
Helping actually individuals understand their personal data is one of the stated goals of Opower. We had some tagline, and we might still use it, something about the goal of Opower is to help people or bring people from out of the dark, something dark, bring people out of the dark, about their energy usage. So the whole idea is, you as a customer, you want to save energy, live in a home, you want your energy bill to go down. We have your data, we have your monthly reads, we have your possibly hourly reads, we have some information about your home, and we want to consolidate it in such a way that you can understand the best way for you to save. Should you buy a more efficient refrigerator? Should you turn off your lights? Are you wasting your time by buying CFLs? Is that really not the main problem, etc.? So that's the core problem that Opower is trying to solve. We do this through a combination of data science, but also have a dedicated UX team that is whose job is to present whatever we've learned or whatever it is about your data to the customer, to the homeowner in a meaningful way that distills it down to this is the best way to save, or this is what you should do. And we also have behavioral scientists who basically train in these issues. What is the best way to incentivize people to save energy? So there really is kind of a meeting of the minds on this. We have proposals that either come from the data science team. We can predict this value, and what can UX do with it to present it to people? A good example of this is disaggregating energy usage. So you get let's say we have someone's electric usage every month. We want to know what percentage of that came from their AC versus lighting versus other appliances in the house. And if a large majority came from air conditioning, we can say, hey, if you turn down your AC, you're going to say that's going to lead to the largest savings. Or if the disproportionate amount is from lighting, we can say do CFL light bulbs, something like that. So if we can disaggregate your energy usage and say this percentage came from this source, then we can help do that. But we also want to, again, present it to the user instead of just giving them a full breakdown of all the, table of all the numbers, probably either some targeted tips. Maybe we do want to give them, more information. And again, so we've done different versions of this based on what, the UX team has decided is, there's just the simple tips that we can give you, but then we can dig deeper and present the information in meaningful ways so that people who are curious about their own data can discover that.
Yeah, we take a very similar approach at BrightBites. That's really the heart of what we do. We have a platform called Clarity, which is really designed to facilitate data-driven decisions for the classroom. And so part of that is collecting all that data and presenting it in a way that educates people and is engaging so they actually use the data, and then most importantly, actionable. So every piece of data that we present actually has a piece of research attached to it, so we're educating people, but also an action. And that could be a short-term action, a quick win, or maybe a long-term action like game changers. And the really interesting thing about taking that approach is that we really see people changing their language and having a common language around how to use data within certain disciplines. So first thing we're tackling is technology in the classroom. So we spend billions and billions of dollars on technology in the classroom, but is it really being effective? And we really provide a language and like a metric to really judge the effectiveness of technology in the classroom. So that's like external facing. Internal facing, really, the idea is that part of my job, I consider part of my job helping everyone understand data better. So, just last week I was teaching one of our customer success officers about signal detection theory, about understanding like false positives, and that basically blew his mind. He didn't really understand like how he could have different baselines and how that could affect the decisions he makes. And having that kind of very simple tutorial with not technical, but just a different way to understand his data really helped him. And then the week before that, I helped a business analyst really understand campaigning and kind of ad targeting using Bayesian statistics. So kind of changing the likelihood of things happening based on certain conditional probabilities. And he was able to handle it in a more technical way, but kind of targeting the right information at the right level. One other thing I do, just for fun, we have like a giant whiteboard walls in our office, and I have a statistic of the day. So I turn statistics into a social object. Social objects is a sociology theory from the 70s that as we look around our world, the human-made world, that we see objects. You can see lanterns, you can see pictures. Those are all social objects. They're meant to spark conversation and meant to be engaging. And I do the same thing for statistics. So I just present statistics every single day that get people talking and make data science seem less scary.
I guess that over with us, one of the key things we think about is it's all about telling stories. So for us, we generate for an individual, what is that patient or that person's story to date, and where is that story going? When we talk about populations, we talk about the population story and where that population is going and where subpopulations are going. And so fundamentally trying to bring the vernacular of how is it one articulates that whatever story you're looking at. And for us, it's a data story. So then we look at it from an issue of the data points and also try to represent things in context. I can say, well, this guy had 5 hospitalizations. Well, is that good? Is that bad? Is that normal? Who knows? To tell you he's an 85-year-old guy who has, congestive heart failure and chronic renal disease, you're like, okay, that's not too bad. This is a 23-year-old who's coming 5 times with an acute something's wrong. So it's a much more worse situation, right? So it's sort of the same facts, but different context. And so a lot of the point of when telling stories is also building the context around it, by being able to explain that context to people. What is that chain of reasoning, that rationalization for what this data happens to mean and what its potential value is to you. And towards your point of saying it's about being actionable, right? It's an issue where you don't want to present people information that's just there and they sort of look at it, stare at it and say, okay, and now what do I do? Where does it relate? How does it connect? Unless we're connecting the dots for people and then connecting that whole series of things into things that they themselves can engage with, interact with. So saying, hey, this person's serum creatinine is increasing, he's a diabetic, therefore his likelihood for chronic kidney disease is increasing, and therefore we're now looking, he's also hypertensive, and looking at his meds, we may want to change his meds, right? And that's something that's meaningful, that's something meaningful for a clinician, that's meaningful for a care provider, that's meaningful for all of us as individuals, like, oh, I should change my meds, this is not good. That's actually really useful, right? And so it's an issue about being able to actionable and being able to tell that story. And the way we think about that is, context, visualizations, narrative, how can we actually construct that automated way of creating a narrative so you can actually read what's going on. And then in some ways we also think of APIs as sort of elements as part of the thing. So internally we're, as I said, clinicians and data scientists, and what are the tools, the grammar, the sentences by which you construct your stories. And in some ways that's the way in which we ideate how we think about our APIs in terms of how they actually provide us the nouns, the verbs, the parts of how to actually tell stories, and we can then put them together in logical ways to actually construct a story at the individual level again at the population. So.
Cool. I think at Code for America, one of the things that we're really acutely aware of is that because we're dealing with the people that are kind of the producers of data in the first place, that there is what I think is a misconception outside of government and outside of the sources of data, that open data is something that exists before it's opened. So people sort of imagine that it's like, oh, if they could just open this stuff up, then we could use it. Why can't they just open this stuff up? But a lot of our education is focused on the producers of this data because you have to actually create it, sometimes out of whole cloth, in order to open it in the first place. So to give an example, we worked on a data standard last year called House Facts. It's visible at housefacts.me. And it's a data standard that focuses on building inspections and violations in a city like San Francisco. So if you think about where that data comes from, it actually comes from 3 or 4 different departments inside a city hall. You've got the GIS people that store information about where buildings are located and what their ID numbers are. You've got building code people that understand kind of what codes are there and what types of violations might happen. And then you have all the public health people that are doing the actual inspections and looking at whether there's rats or vermin or other kinds of things in buildings. And so convincing and educating all of those different people that there's some kind of advantage or benefit to sort of pooling their resources is a really, really big deal. Helping them see that there's some kind of reason why they might even want to talk to each other. In a lot of cases, they don't really like talking to each other. Further down the chain, there's the actual data format or data standard itself. In the case of House Facts, we went for a comma-separated values, kind of 3-file-based format. And part of the idea there was to develop a data standard or data format that could be produced by people with a kind of, Microsoft SQL Server, Excel level of tooling or experience, which basically means like desktop computer type analysts. It was really important to us that this not be something that had to go on a full loop through the IT department to be turned into like JSON or XML or something, because the fewer people you get in that process, the better chance you have of the data actually making it all the way through. And then finally, at the other end, we created a very simple, very basic kind of demo mobile application for San Francisco's data in order to show all of these people earlier in the chain that there is some benefit to doing this stuff. Very simple application. You can kind of put in an address, or it figures out where you are based on W3C geolocation, and just shows you the kind of red and blue dots around you for houses that have had or have not had violations at some point. So just doing a basic visualization like that and putting it into people's pockets on their telephones was a way to show them that there was sort of a benefit to this stuff that wasn't just kind of an abstract, I don't know, nerds kind of scratching at the door type thing.
And just to jump up on that, I think just as people say, oh, it's open, it's, why don't they just enable it and put it up, etc. I think, at least in our experience, and I'm hearing that it's true in other places, it's nice to think that the data is there. We all hope the data is there. Sadly, what we find most of the time, the data is not there, or at least not in any way that you can actually leverage. And so that's one of the things that I think we've been learning almost continuously on almost every single aspect. And sort of hearing echoes from that from everybody else is, you got to go and work with the people. You got to go and spend the time. It's not fun. It's not exciting. A lot of the work is that until you can get to the exciting stuff. So, we have to be patient and we have to support people to actually work, and we have to also show them the reasons as to why they need to do that, because they've never thought about it in the way you have. I mean, to you it's obvious. It's like, well, why wouldn't you do this? How else would you go ahead and solve and do this and do that, etc.? They never thought of that. So, I mean, you have to work with them to really educate them on that aspect as well. So.
All great stuff. This is the point of the night when I get to open it up to the audience. So hopefully you've been thinking, you've been pondering questions that you want to ask the amazing panel up here. If no one has any questions, I could go on all night, but I hope and imagine you do. In the back there.
So, if anyone had any use case for real-time analytics based on a situation where you want instant outcome, what is the best methodology to do that? And is there a use case that you face?
Can you repeat the question, Joe?
Yep. So the question was about real-time analytics and what are the best practices for dealing with data that's coming in real time and potentially have to give insights in real time, and a specific example if you have one.
Yeah, so for us in health, it's somewhat straightforward. If you want to be used at any point of care, if you want to help people make a decision like, do I eat this or do I eat that, or do I, whatever it may be, you got to give a response in about 100 milliseconds, right? You got to be able to, and then hopefully even the network is not failing you entirely, it gets there in less than a second, right? So we do that a lot of how is it that we can take an individual, so let's say we've done stuff with nurse call centers. Someone calls in, they're having a problem. How do you help that nurse know what the right questions to are and know where to potentially go ahead and send this patient for the right level of care, right? And that has to be interactive, that has to be fast, that has to be usable. And so there's a lot of different things you got to think. You got to architect the way your system is to think about what is my analytic model. You're probably not going to train your model in real time and then apply. It's a lot of going to do a lot of learning beforehand, creating models that then can be computed very efficiently and very, in a time frame. Deal with what level of complexity you're talking about and figure out a way of delivering that. So how do you take in the data, how do you store the data, how do you analyze the data? So I don't really think about the architecture of all of that. And then as you take those streams of data and learn things about them, it's more of a batch sort of process in which then you're creating learnings, driving new models, etc. So I don't know if that exactly answers your question, but you do have to be very thoughtful about what does real-time or real-time really mean, and subsequently the systems you use will be very different than if you can go through and do other stuff, right? So one of the key mantras is sort of what I talk about is bring the compute to the data, not the data to compute, right? And there's a massive difference in performance you're going to get. And so then you look at a lot of the sort of new architectures like that, and that's sort of where things are moving.
Yeah, I have a personal passion for Internet of Things, and I think right now we're on the cusp of a whole new generation of tooling. So if you're interested in Amazon Web Services and use that, they have a new offering called Kinesis, which allows you to process real-time streaming, and then kind of built on an open source platform through the Apache project is Spark and Shark, and those all make that kind of analysis and understanding of real-time data accessible to a lot of people, and that's the kind of stuff that I like to play around with on the weekends.
So both of this definitely rings true as well for us. Most of our analytics, some of our analytics is actually real time. We use Mixpanel, which is basically a tool which anyone can use with the right boot camping, and basically you're just pushing events to some kind of sync, right? It can be Kinesis, it can be Flume, it can be any kind of aggregator, and then you want to process this stream of information. And this is where your use case matters. And it also depends on how real time you need the information. And depending on your use case, you're going to be able to take a lot of shortcuts, which are going to be crucial for the success and simplicity of your infrastructure.
So I saw a hand up front here.
For each of you, there's two questions that come to mind. First, thanks for all the sharing. I can think of in each of your cases where it's incredibly valuable to bring in data from another domain. And maybe you already have it. For instance, in Opower, it may be that it's weather information and microclimates patterns, things like that. And something like change.org, maybe there's things in political databases or whatever. For each of you, what domain of information would you like to be able to go out and grab right now that feels like it's out of reach? And how would it change the way that your organization runs?
So just repeating the question. So for each of you, is there some domain of data that you wish you could get and just had that currently is inaccessible or out of reach? And how would things change if you had that data and you could work with it?
I mean, that's most of my job is trying to understand education data in the United States. And so if that data was actually in some kind of API that I could query, and I wasn't building the API for that, that would be, I could be doing a lot of other stuff. It's really interesting because looking at other countries, they have a very different way of handling it. It varies across different countries, but some countries have a very mature way of handling data and understanding it and making it presentable to different audiences. And it's a delight working with those other countries, where the United States is kind of very immature and very kind of siloed for different levels in a hierarchy, and then across that.
For us, sort of I won't say orthogonal, but different data set that would be very fascinating is fundamentally social data or social behavioral data. If you think about what the determinants for health, there's obviously the clinical realities, the pathophysiology, what's going on. But one of the things that, very interestingly enough, in our analysis of understanding how diseases connect with each other, we found depression and anxiety to be the really core of how the actual progression and manifestation for many diseases are, and it's actually quite much higher prevalence than you would actually think. And so being able to combine what we have with the sort of data sets about the social behavioral dynamics of people and able to bring that in, not only by themselves, but actually I would call their social graph aspect of things. Because if I'm recently, discharged from a hospital due to an acute event, understanding the care or the social structure able to provide it to me is going to change my perception of your likelihood to come back. Right, and so being able to pull that and having that information, I think, would allow us to become tighter, smarter, and better about, I can discharge this patient because I know his social support structure over there is at this level. However, if the situation was different, I would want to keep him one more day. And so it's being able to have that level of nuance, which is actually very important. So that's what I would say is sort of a data set that would be fantastic to be able to pull in and really help hopefully drive better care.
Yeah, I think I would echo the focus on social data as well, especially for city governments and county governments. They're very, very experienced in kind of being the holders of data and publishing it out, and they're much less experienced in input and feedback. And so we're trying to figure out ways to get kind of open or social data sources available to cities. So things like, on city websites to get Google Analytics going in such a way that the people that are actually publishing and writing this stuff can see what's going on and who's actually visiting these things. For GIS departments to be able to see OpenStreetMap data in some kind of usable form so they can understand where their GIS data might potentially be out of date and need some sort of information. And then for general cities, things like Twitter or Facebook, to be able to see what people are just kind of saying out there, the kind of human shot spotter if there's some sort of crime that happens on a block, or people's general satisfaction or dissatisfaction with things would be amazing. And a lot of the challenges for these things just have to do with kind of bridging that gap between the kind of API talk of the social web. Now Twitter requires OAuth in order to get its streaming API. It's completely insane. People in cities are having a lot of trouble with this kind of stuff. So how do we help bridge that gap?
I had to think about it for a second. That's a great question. For us, I would say some data, which there are a few ways we can do it, but to give us the means to disaggregate down to the second or some much finer granularity of time, but also per appliance. So basically, like your refrigerator is cycling right now. This light bulb is on at this time. So if we had, there are things that plug into particular appliances. That is a little unrealistic that we're going to get that on a large scale anytime soon. Hopefully, the world's going to move in that direction. But if you can get smart meters that actually go down to sub-minute, you can get that using disaggregation algorithms. And they're either established algorithms or we think we can solve that problem ourselves. And that really, I think, is like the gold standard of where we can start to give really, really targeted advice and say, this is absolutely the way that you can save, but also just give people visibility into what is going on in their home. Right now, there's we do as much as we can. There's a limited amount of information you can extract from either monthly or even hourly reads, but if you can get down to these lights are on at this time, especially compared to your neighbors, this is the best way to save.
Right, so you already got weather data, microclimate weather data?
We have, I would say, sufficient weather data for our needs. More data is always better. If we can get like more weather stations, that would be great. But the energy usage per sub-minute is really a much bigger deal for us, I'd say.
So we also have a holy grail of data at change.org. It's what we call the power graph. So the power graph is how decision makers interact. Which decision maker can influence another one. And so a simple example is about a year ago, we got a pretty big victory, which was ending the ban on gay Boy Scouts. So that was due to a lot of campaigning on change.org. And the reason this worked was that our staff and a bunch of petition creators created a bunch of petitions targeting the sponsors of Boy Scouts of America, because they knew that directly targeting them was not going to be like the most easy. It's not going to be the easiest path. The easiest path is not always the most direct path to a decision maker. So if you want a change to happen, sometimes there's a longer path, but which is actually easier. And in this case, every single sponsor of Boy Scouts America dropped their funding on Boy Scouts from pressure. And then the petition creators finally got the attention of the Boy Scouts like this. So it's around getting data and insight, which some campaigners have. So how can you sort of find a process to sort of build this graph, which is going to be hugely impactful.
Yeah, speaking of that, there's a data shop called Fathom that has a power graph for Chinese politics, and it's pretty amazing to see that because you can see the actual hierarchy in Chinese politics, and you can kind of see the behind-the-scenes hierarchy, and a lot of that's influenced by history, and they actually did a way to plot the history of Chinese politics, and it's a pretty amazing way to like understand how decisions are actually made in the real world.
Awesome, awesome stuff. I think we're running a little short on time. I'll say we have 2 more questions. Going to this side of the room, I see a straight arm over here.
So this is a softball question, but what do you guys think for each of your companies? What's your biggest win? Like, what was the question you answered that like really kind of did the most good in terms of the good through data science theme? Nice talk.
All right, so the question is, what was the biggest win? Which is the thing that you've done that has had the most success and impact? And I'm also going to add a little asterisk addendum. How do you and your company measure success? And this could be most people affected, most people impacted, most money saved, most energy saved. So what are your key metrics for defining your success, which often is difficult when you're dealing with social good? And which was your biggest success?
Yeah, I think for Code for America, probably our biggest success ongoing over the years is getting conversations around design and user feedback and direct creation of technology and agile methods into the conversation around government. It's just never been there before. Government is a classic waterfall user, and so getting governments thinking about this stuff and realizing that it's not just something for all these left coast people, but it's something that they can actually kind of do themselves is huge. In terms of key metrics, I think we try to encode that into things like prevalence of chief data officers or number of open data sets that have been released or particular types of actions that cities have taken.
So I guess one of the things that we found to be really impactful was helping identify what diagnoses are being missed within populations at an individual level. So really looking at people's data, looking at it temporally, looking at how, if you look at the total set of data about an individual, what is actually being indicated that people are otherwise missing. So are people who have congestive heart failure not being identified, people who have chronic kidney disease and things like that. And those are actually very meaningful things because that's going to change the way you want to manage that patient. It can actually hopefully lead to much better outcomes for that individual. The way we sort of measure that is, how many people, have we affected? So, how many lives have we touched? How many patient years have we analyzed? And then what we are right now working on creating metrics is what is the not only the social but more the clinical or health impact that we've been able to have by identifying these facts and how does that improve people's lives. So that's some of the things we're right now working on, so that we can really say this is the quote quantity or measure of that value that we've been able to bring to the table at the individual level and then also in the population.
Our biggest win is the platform we've created, in the sense that education and data have typically been at odds. Usually data is showed how poor of a job you've done. The United States is lagging in education. We have all the data to prove that. Or your school is not doing well, and we have the data to prove that. And we're really changing the conversation around data and getting the people in education to really engage with data and decide what it means to them and how they can best use it. And the success is that we're serving thousands of schools and millions of students, and that's the kind of metrics that we really care about.
For us, it's simple. It's energy saved. We are a double bottom line company. At every quarterly meeting, the CEO announces profit and also energy saved, and it's just essentially the core of what we do. It's the top of our website. We have saved, it's either 3 or 4, whatever, some number of terawatt hours. And I should have looked all these factoids up before I came, but we've taken some city like St. Louis, the equivalent of St. Louis off the grid. It might be Vegas now. It changes because we keep saving more and more. But it's basically energy saved, and mostly through these paper reports that we send out, and certainly through a bunch of the other products we do, we get people to save energy. We have robust statistical models that measure the savings. We have randomized control studies for every pilot that we do that has a control group and a treatment group, and that's how we were able to get these numbers accurately. These are sort of government approved and also statistically robust.
So working at Change.org is kind of awesome for this because we have impact every day. We have victories every day in every single sector, in every single cause you can think about. And so a couple of things. The way we measure success, so we have a bunch of multiple metrics which some different product teams track, but we have what we call a big, hairy, audacious goal, which is like a long-term vision, which tries to encompass a lot of different metrics. And our goal is to increase the number of users experiencing victory, because this means that you are actually increasing victories, and you're also increasing your growth. And right now we're at 20 million users experiencing victory. And in terms of machine learning, this is also awesome, because I remember about 2 months ago, I had a campaigner thanking me personally, because thanks to machine learning, we managed to find the audience for a petition which was basically controversial and really impossible to sort of target other than through machine learning. And we managed to find a set of people, and because we find this core set of people, with cluster of people which was who was interested around this petition, we managed to get a victory. And yeah, it works. We increased our signature rates by 70% in the last year thanks to machine learning, and we can see the impact of this every single day.
So wrapping up, time for one final question. So you have your hand up the whole time. I'm sorry I missed you, but now's your chance.
Do you ever have bad data or data that you need to discard? How do you decide? Do you make bad predictions, or are they really dirty? How do you decide how to throw away data from the big data scenario?
Yeah.
I'm sorry, just going to repeat it for the video and the recording. So how do you determine if you have bad data, and what does bad data mean for your company? Is it data that gives bad predictions? Is it data that's just too messy, takes too much time, too much effort? And also I just wanted to add, if you could give an example of something that just didn't work. You'll hear about all these successes of machine learning, but you never really hear about when things just don't work, things you just can't model, things where it's just too gross or messy or in some form.
Sure. So yeah, basically machine learning is data in, data out, usually predictions out, and depending on what kind of data you put in, you're going to have different kind of performance. And it's interesting around, so your data landscape is huge, right? There's social information, there's stuff you can collect on your website, there's user behavior, there's demographics. So you have more stuff to try out than you actually can possibly do. And there's always the underlying assumption that demographics is predictable information for people who don't know data science. Demographical data is actually not that predictable if you have already behavioral data. By behavioral data, I mean stuff that people do on your website. This usually supersedes any kind of demographical information. So obviously, demographical information is better than nothing. But once you have enough data around a user, this behavioral information usually supersedes that. And yeah, it's interesting how some of your assumptions actually don't work out, and you're really thinking that this specific data point was going to work, but it actually had no impact whatsoever on your model. It's really funny.
For us, there's a lot of domain. Well, what bad data means for us is on the energy usage side, we do get bad readings sometimes from the meters themselves or from the utilities, and we just have domain experts or people on our side that have set up rules to, just the dumb way of doing it, just to say like, negative value, kick it out, or if it's too high, then kick it out. Since the data science team formed, we've been, at least the models that we've been building, it really is the second thing you said, which is a little bit of domain expertise, but also does it make good predictions? That's really the bottom line. The goal of our team is to make predictions and deliver those, and so we will apply the domain expertise, but maybe parameterize the threshold at which you kick things out, or parameterize the rules for how you denoise data, and then search over those parameters for what makes the best prediction. That's really, I think, the best way to do it. And honestly, there's stuff that has been done in Opower in the past that we should probably apply that principle to that we haven't. It's a little hard because they're entrenched systems, but and the truth is, domain experts are generally good. But that I think is the better approach. I'm going to pass on the second part of what doesn't work. It's the thing I just thought of. I realize we can't talk about yet, but.
For us, it's a relative definition of bad or messy data. So what we did was, when we approached education space, we're like, which data can have the biggest impact? And we started there. And we think achievement data and having kind of the best measure of achievement data is the way to approach that. So we started there, and from there we're kind of expanding to other disciplines and other domains. And we kind of look at that hierarchy where the schools themselves are the hardest to access but have the best quality data. States easier to access, but like little older, a little messier, and then the federal government, which tends to have the most complete and easy to access data, but it tends to be very dirty and also little dated. One thing that is kind of funny about what didn't work, so we came in and we were writing a series of web scrapers, and we came through first pass and took a lot of achievement data off a lot of websites, and we were coming through for second and third passes, and some of the data was gone. So basically we just missed the opportunity to get that data because we had created this kind of prioritized queue for web scraping, and when we came back around the second time, the data just wasn't there in any format. It was just gone. And we were kind of surprised that over the course of a couple of weeks that the data landscape would change that much. So for us, especially as I was talking about healthcare, there is, EHR data does have quite a bit of dirty data, and so you just can't randomly utilize it to learn things like that. So you need sort of external orthogonal data sets to really help you sort of filter, clean, and verify that the data that you're reading is actually meaningful, right? And at times that's having curation by physicians for us, or other aspects. So we definitely have dirty data, but there's sort of strategies you can utilize to help you identify the data. One, from an issue of prediction capability, but also from an issue of, are there, there's ways of voting and looking at this information. I have 3 different copies from 3 different people of this data. How do I potentially verify that what is correct versus not? Sometimes, funny enough, we look at some data, which gender is correct versus not, and then we go through and look at actually the things that occurred for that person, and we say, oh no, that's definitely a guy, right? So, that sort of ways you can cross-check that information, and it's the ability to understand how the data connects to each other, and how you connect the dots that will allow you to start sort of correcting the data errors that you have.
I think for civic data and civic tech data, badness is really a function of kind of poorness of fit between a format and the actual data you see. So to give an example, 2 years ago in 2012, we were working with a city that was really interested in open through and one data. For those of you who are familiar with 311, it's basically like the phone number that you dial in some cities to complain about things like pothole in the street, burning mattress in the middle of the street, bum yelling at me when I try to get in my office, whatever. So Open 311 kind of promises to be something like an issue tracker for cities, a little bit like GitHub issues. And we ran into two big issues with the format of the data, or the spec for the data, that were really quickly surfaced in trying to work with the city. So in one situation, we basically found that the closedness of a ticket was kind of up for grabs as far as the format is concerned. So with this particular city, we would find that when somebody on the city side would close a ticket, what they meant was, I passed this ticket off to the responsible party, but the pothole may well still be lying open on the street. So there was a big mismatch between what a closed ticket meant as far as the user's experience versus the person who was on the other end of the line at the 311 office. In that same city, we also found that the spec used the word may in it at one point, like a location may be specified as a latitude, longitude, or as an address. And so the people who implemented the data publishing interpreted that to mean that they could decide which of those two they felt like supporting. And the people on our end who were writing a visualizer for this thing interpreted it to mean that they could decide which of those two things that they felt like supporting. So of course the situation arose where the people producing it were like, addresses are super easy, we don't have to geocode these things. And the people consuming it were like, lat long would be super easy because then we don't have to figure out any kind of reverse, geocoder thing. So both sides punted on geocoding, and you ended up with a totally incompatible visualization running off of something that was technically on spec. So specs are really hard.
Well, that unfortunately brings us to the end of this lovely panel that I enjoyed moderating. I want to take time to thank the panelists for spending this evening. It's rainy, it's kind of cold, of coming in and sharing their personal stories.
Thank you.
And I also want to thank TAG for being an awesome company and for always being friendly to us, hosting us in their space, working with us, and just teaching us new things about data science every time we talk to them. I'm going to hand it off to Katie, who's going to wrap up things and give you some information about how to stay involved and do awesome things with data science.
Thanks, Jonathan. Yeah, thanks again to our panelists. That was seriously awesome. I'm excited to share this with some people who were on the wait list and did not get in last minute. But also, thank you to you guys out there in the audience. This meetup happens because you want to come to it, and we're really super excited about it. And I want to reiterate, if you are interested in becoming as awesome as these folks right here, and doing data science in a sort of good space or at a company like Tagged, we know all kinds of cool companies that do really interesting things from both the processing side and the engineering and machine learning side. And if you want to increase your skills to be able to do something like this, we have open applications right now for our May cohort of Zipfian Academy, and also have all kinds of things running all the time where you can get involved. If you want to hire from our program, I'm happy to talk to you about that. If you want to come speak at the meetup, if you want to host a meetup, if you want to do anything more involved in data science, I can probably direct you in the right direction. That is my specialty. But again, thank you for coming. I look forward to seeing you in about a month. We have a data science, data engineering thing in the works with some people from Sharp. So again, thanks a lot. Have a good night.